All righty. Let's rock and roll. Chapter 7 on antennas. Antenna basics, dipoles, ground planes. Effects of antenna height and polarization, how Yagis work. Loop antennas, antennas with special characteristics. Feedline basics, and SWR and impedance matching. 5 sections, 59 questions, only 23 pages. This will go pretty quick, I bet. Whoa, look at that eye chart. First 20 questions. Okay, let me move this out of the way so I can read the entire question. What is the purpose of a capacitance hat on a mobile antenna? A, to increase the power handling capacity of a whip antenna. B, to allow automatic band changing. C, to electrically lengthen a physically short antenna. Or D, to allow remote tuning.
Charlie.
No, it's to be fashionable.
Yeah. Depends what kind of hat.
Look cool. It's to protect the antenna from rain.
That's
I've never
right.
seen anyone try to remote tune a mobile antenna, though.
Yeah.
What is the purpose of a corona ball on an HF mobile antenna? A, to narrow the operating bandwidth of the antenna. B, to increase the Q of the antenna. C, to reduce the chance of damage of an antenna should it strike an object. Or D, to reduce the RF voltage discharge from the tip of the antenna while transmitting.
Delta.
Delta is correct.
You need to remember that the magnetic energy is maximum at the bottom of the antenna where you're feeding it on a quarter wave, and the electrical energy is maximum at the top,
Yep.
and that's where your sparks are going to come off.
Does that apply the same for a UHF VHF antenna?
Yes, I had a neighbor down here at the end of the street, and he put his vertical behind his 2-story house and by a 2-story garage and another house. He could not talk to California because it was developing the magnetic portion of the wave with all the buildings around it. So he moved it to the northwest corner of the house, where only the house was blocking a quarter of the wave, and he could talk into the nets on 40 meters.
Well, the actual corona ball itself, kind of more of a tech question I should ask maybe tomorrow, but the ball itself being there or missing on the antenna for VHF, UHF.
If the ball is not there, your antenna comes to a sharp point, and you're going to have arcs coming off of that, particularly in the rainstorm. You put a ball up there, you have a little bigger surface, and it's not going to arc off of it.
Yeah. I remember on a trip from Colorado up to Everett, Washington, my dad back in the day, in the 70s, had CB radio, and it had the little ball on top. And we were driving down the highway and going through thunderstorms and stuff, and we could actually see the little sparks and stuff coming off the top of the antenna. We were going, wow, look at that.
It's pretty cool.
Pretty
Would the
cool.
Jack-in-the-Box ball work too, or no?
No, I think you want metal.
Oh,
Yeah.
okay.
If you cover it in tin foil,
Yeah.
Make the Jack-in-the-Box hat tin foil.
Yeah.
my dad was in avionics for Boeing's, and he would get mad at the pilots because they had a long wire that extend out with a ball on the end of it, and they wouldn't bring it in when they're landing. It had knocked the ball off, and they had to replace the ball on the wire all the time.
Oh, wow. What is one disadvantage of using a shortened mobile antenna as opposed to a full-size antenna? A, short antennas are more likely to cause distortion of transmitted signals. B, short antennas can only receive circularly polarized signals. C, operating bandwidth may be limited, very limited. or D, harmonic radiation may increase?
Early.
Charlie.
Charlie is correct. Your operating bandwidth may be very limited. Which of the following is a common way to adjust the feed point impedance of a quarter wave ground plane vertical antenna to be approximately 50 ohms? A, slope the radials upward. B, slope the radials downward. C, lengthen the radials. Or D, shorten the radials.
Bravo.
Bravo is correct. Slope the radials downward.
Why is that, Daniel?
We're looking at a vertical, a quarter wave is 35 ohms. You're looking at a dipole, you're 72 ohms. So if you got the radios kind of as the other half of the dipole, when you bring it from 45 degrees out downward, you're going toward that 72 ohm situation, and you'll find the 50 ohm in the way going down. Until you're about 22 and a half to 45 degrees down.
Good. Thank you much.
Which of the following best describes the radiation pattern of a quarter wave ground plane vertical antenna? A, bidirectional in azimuth. B, isotropic. C, hemispherical. Or D, omnidirectional in azimuth.
Delta.
Delta is correct. What is the radiation pattern of a dipole antenna in free space in a plane containing the conductor? A, it is a figure 8 at right angles to the antenna. B, it is a figure 8 off both ends of the antenna. C, it is a circle, equal radiation in all directions. Or D, it has a pair of lobes on one side of the antenna with a single lobe on the other side of the antenna.
Alpha.
Alpha is correct. We have to visualize it. It is a figure 8 at right angles to the antenna. Alpha is correct. How does antenna height affect the horizontal or azimuthal radiation pattern of a horizontal dipole HF antenna? A, if the antenna is too high, the pattern becomes unpredictable. B, antenna height has no effect on the pattern. C, if the antenna is less than half a wavelength high, the azimuthal pattern is almost omnidirectional. D, if the antenna is less than half a wavelength high, radiation off the ends of the wire is eliminated. Correct answer is Charlie. If the antenna is less than half a wavelength high, the azimuthal pattern is almost omnidirectional.
Is that the effect of the NVIS antenna then? Another way of saying it?
Yes, it is. And normally we think of that as a eighth of a wave off the ground, not a half wave. So that's a little misleading. I don't like the question because it starts at a half wave, and we normally think of a NVIS as an eighth of a wave up, or 10, 15 foot up, and then becomes omnidirectional. It's using the ground as reflector for the dipole, and it's shooting the energy almost 90 degrees straight up.
Yep.
And at half wave, it starts to do that, but at an eighth of a wave up is when it's going almost straight up vertically, and then bounces back in about a 250 to 500 mile circle. They'll say 300 miles, I think, in the test.
Okay. Where should the radio wires of a ground-mounted vertical antenna system be placed? A, as high as possible above the ground. B, parallel to the antenna element, C, on the surface of the ground or buried a few inches below the ground, or D, at the center of the antenna?
Charlie,
Charlie is correct. How does the feed point impedance of a half-wave dipole antenna change as the antenna is lowered below 1/4 wave above the ground? A, it steadily increases. B, it steadily decreases. C, it peaks at about 1/8 wavelength above the ground. D, it is unaffected by the height above ground.
bravo.
Bravo is correct. It steadily decreases. How does the feed point impedance of a half-wave dipole change as the feed point is moved from the center towards the ends? A, it steadily increases. B, it steadily decreases. C, it peaks at about 1/8 wavelength from the end. Or D, it is unaffected by the location of the feed point.
Alpha.
Alpha is correct. It steadily increases. Which of the following is an advantage of a horizontally polarized? Is there words behind that? Nope. I need to move my screen a little bit more. As compared to a vertically polarized HF antenna. A, lower ground reflection losses. B, lower feed point impedance. C, shorter radials. Or D, lower radiation resistance.
Alpha.
Alpha is correct. Lower ground reflection losses.
Why would that be, Daniel?
If some of these are tricks of the following advantage of a horizontally polarized as compared to a vertically polarized antenna.
I don't have a clue.
Horizontally polarized as compared to, and our answer is A, lower ground reflective losses. Your vertical antenna, the other half of it, the counterpoise that they call it, would be the ground. And if you put radios out there, you'll fix it. If the radios are there, if you don't have the radios, you're going to be working off the water table in the ground as a reflector on that. So the vertical antenna is really tied to the ground unless you have radios out there. The horizontal is an antenna by itself. You got the counterpoise on one side and you got the driven on the other side.
Ah, okay, thanks.
It's kind of balanced. Is that making sense?
Yeah, plus it has a lot less terrestrial noise too, the horizontal.
Right. It's a lot less man-made noise on the situation. And like I said, that's a good reason you put radios in here, because if you're in a wet ground, your water table is pretty close to the surface. If you're in dry ground like Arizona and sand, it can be way deep, and your vertical antenna is not going to work very well with that. It doesn't have something to bounce against to get off of, if that makes sense.
Yep.
So that's why you put radios out there. It fixes your ground or your counterpoise for your vertical when you put radios out there.
So let's all have beams. Yankees.
Well, if you can, but on HF, it doesn't matter after it gets the first hop. When it hits the sky, it goes, I think I'm just missing the word, but it comes back. So a little bit off of it's not either vertical or horizontal polarized. So it doesn't matter at the other end on HF after the first hop.
Oh, yeah.
But locally it does. My nephew was complaining he could not hear people on 10 meters locally, and part of that was polarization.
Cool. Okay.
What is the approximate length for a half-wave dipole antenna cut for 14.250 megahertz? A, 8 feet, B, 16 feet, C, 24 feet, or D, 33 feet?
Delta.
Correct answer is delta.
So
And they're
where's the
using,
Jim, where does the 492 come from? I couldn't find that in there. Maybe it was in there, but I couldn't find that.
That is going to be your English standard. That's not metric in here.
speed of light.
Speed of light.
It's a speed. Yeah, that's going to be the metric in here. You need to recognize that's 20 meters. Half of 20 meters is 10 meters. 10 meters converted to feet is going to be 30 plus feet. And the only thing there 30 plus feet is D. That's the easy way to do that.
But what's the 492? You said 492 is the speed of light?
No, it's
No.
Well, it's in feet with megahertz, with the appropriate factors in there.
Yeah.
I'm surprised they brought this question back in here because we've gone into metric on all the antenna and questions for 10 to 12 years. So I'm surprised they brought this formula back in here, but this is in the feet, converts it into feet. 186,000 miles per second. And the 492 is one of the formulas to calculate into feet.
Okay.
Now, they have not taken into consideration that it's probably a wire dipole and it's 95% this length. So we normally consider 32 foot, 32 and a half foot for the half-wave dipole.
So on page 7-3, even though this says 7-4, 7-3 finally calls it out. In free space, a half wavelength in feet equals 492 divided by the frequency in megahertz.
Yeah, I'm just wondering where the 492. I mean, is that just some constant, or is that, again, it sounds like it's
It is a constant when it's compared to the speed of light. Yes.
okay. All right.
To get it into feet, but you're also looking at the speed of light as 186,000 miles per second, not 300 million meters.
Right. Okay.
We're just not sure how they derived the 492. That's all.
It's
Yeah.
easier to say this is a 20 meter dipole. Half of 20 is 10 meters times 3.3 will get you right up there to 33 feet.
33 feet. Yep.
And I want to show you the second way of looking at it, so you confirm your answer.
Do you have it ready, or do you want to do it at the end?
No, that's fine.
Okay.
Normally what we do is 300 divided by your frequency, and that'll be in meters.
Yeah.
So 300 divided by 14.25, and then you multiply it by 3.3 to get into feet.
Okay. Yeah, because even in the Dave Kassler videos, he was going, I don't like the 492 because it doesn't, that's in best instance, and you have the wire and loss of the wire and everything else. And I remembered I was like Dave Kassler. I remembered 465 for some reason. So, well.
So and that's your 95% of your velocity factor considered in there. But
Yeah.
I'd rather go the 300 divided by your frequency, get you the meters, and then cut that in half to make a dipole and multiply it by your conversion is 3.3.
Yeah, makes sense. What is the approximate wavelength for a half-wave dipole antenna cut for 3.550 megahertz?
Or 80 meters.
Now that's 80 meters. So half of that's going to be 40. 40
Uh-huh.
times 3 is 120. What's close to 120?
C.
Charlie is correct. 132.
C, senor.
Sí, señor. What is the approximate wavelength for a quarter wave vertical antenna cut for 28.5 megahertz?
10 meters.
That's 10 meters. 10 meters, a fourth of that's going to be 2.5 meters times 3 is 7.5, almost 8 feet. Is there an answer in there? Yeah, there it is.
There it is, alpha, 8 feet.
246.
And
And
246,
Daniel, you didn't even need my hands.
I didn't use your hands. Yeah. I kept my shoes on too.
I'm
Yeah,
glad.
thanks. Yeah, the 246 is half of the 492.
Well, at
Yeah.
least we know where that came from.
Got it. Yeah.
How does antenna gain stated in dBi compare to gain stated in dBd for the same antenna? A. dBi gain figures are 2.15 dB lower than dBd gain figures. B. dBi gain figures are 2.15 dB higher than dBd gain figures. C. dBi gain figures are the same as the square root of the dBd gain figures multiplied by 2.15. Or D. dBi gain figures are the reciprocal of the dBd gain figures plus 2.15 dB.
Bravo.
That's creative math, guys.
That
No,
is
the
some
DB
fun.
the DBI is an isotropic. It's like a soccer ball. It doesn't exist. We've never been able to build one. So it is adds 2.15 dB to the DBD. DBD is a dipole. We can
So what-
measure the dipole.
What's the purpose of having the DBI as a item?
Well,
Just-
it is a standard.
I mean, it's
It's
like
an
using
imaginary
commercial.
standard they can go off of. And some you got to watch your manufacturers because they'll quote it both ways. You got to understand which way they quote it.
Wow.
And it's the same antenna, the same gain,
Hmm.
and they just quote it in dBi or dBd.
And when,
We would,
yeah, like
go
in
ahead.
D though, it says 2.15 dB. So it's, yeah. So what's a dB compared to the other two, dBi and dBd?
dB a dB is an input to output, comparing one number to another one. A dBd is comparing this antenna to a dipole, and
Ah,
dBi is comparing it to an isotropic.
got it. Okay, thank you.
When you added the extra letter in there, you're comparing to a known antenna or a known number.
Gotcha.
What is meant by the terms dBi and dBd when referring to antenna gain?
There you go.
A. dBi refers to an isotropic antenna. dBd refers to a dipole antenna. Yeah, we just talked about that.
Let's talk about that.
Next question.
Alpha. Which of the following antenna types will be most effective as near vertical incident skywave or NVIS antenna for short skip communications on 40 meters during the day? A horizontal dipole placed between 1/10 and 1/4 wavelength above the ground. B. A vertical antenna placed between 1/4 and 1/2 wavelength above the ground. Or C. A left-hand circularly polarized antenna. Or D. A right-hand circularly polarized antenna.
Alpha.
Alpha.
Alpha is correct. What is the feed point impedance of an in-fed half-wave antenna? A. Very low. B. Approximately 50 ohms. C. Approximately 300 ohms. Or D. Very high.
Delta.
Delta is correct, very high. How does a screwdriver mobile antenna adjust its feed point impedance? A, by varying its body capacitance. B, by varying the base loading inductance. C, by extending and retracting the whip. Or D, by deploying a capacitance hat.
Bravo.
Bravo is correct, by varying
Great
the
like a peasant's hat. It's really a
yeah,
key there.
deploy that capacitance hat. What is the common name of a dipole with a single central support? A, inverted V, B, inverted L, C, a sloper, or D, a lazy H?
Alpha,
Alpha is correct, an inverted V.
lazy H.
Lazy H.
We're talking about that screwdriver antenna. I thought we were gonna have a plier antenna to adjust it.
Oh, yeah, there you go. How about a big hammer antenna?
And the hammer antenna, if it doesn't work, yeah.
Would that be a Phillips screwdriver or a straight blade screwdriver antenna?
It's probably a straight.
All right. Everything about Yagi antennas in 11 questions.
Or as Toku would say, Yagi.
Yagi. Which of the following describes an azimuthal projection map? A, a map that shows accurate land masses. B, a map that shows true bearings and distances from a particular location. C, a map that shows the angle at which an amateur satellite crosses the equator. Or D, a map that shows the number of degrees longitude that an amateur satellite appears to move westward at the equator with each orbit.
Bravo.
Bravo is correct. A map that shows true bearings and distances from a particular location. I liked Dave Kassler's with string in the map or the globe that he had. That was pretty cool. If you point west, you're going to end up somewhere down in Africa. If you point kind of north east, you're going to end up in France. Pretty cool. Which of the following would increase the bandwidth of a Yagi antenna? A, larger diameter elements. B, closer element spacing. C, loading coils in series with the element. Or D, tapered diameter elements.
Alpha.
Alpha is correct, larger diameter elements. What is the approximate length of a driven element of a Yagi antenna? A, 1/4 wavelength. B, 1/2 wavelength. C, 3/4 wavelength. Or D, 1 wavelength. Driven element is Bravo, 1/2 wavelength.
A driven element's going to be okay. The driven element should be a quarter wave and you can drive half of it and the other half of it. It's a half wave dipole, but it should be only a quarter wave driven.
Uh-oh.
The center pin goes out to one side of it.
Okay,
another way to look at it.
9C2.
Yeah.
Huh. Well, on page 9 or 7-10, it says the driven element DE is a resonant dipole approximately half wavelength long.
Yeah, you
And
can turn both sides of it that though. The driven's only one side of it. The shield goes to the other side. So that's why I have a problem with that question.
Yeah.
Interesting.
Unless they're talking about the shielding being part of the driven element. It's all one piece. I don't know.
Yeah, but the antenna is a half wave long. Yes.
I think that's what they're after.
Yeah. Pass the test. Don't worry about the, the
Yep.
Yeah,
Don't think, memorize.
yeah. So this one says half.
So you go, huh, that question. Oh, yeah, B.
yeah.
How do the elements of a 3-element Yagi reflector and director compare to that of the driven element? A, the reflector is longer and the director is shorter. B, the reflector is shorter and the director is longer. C, they're all the same length. Or D, relative length depends on the frequency of operation.
Alpha.
Alpha.
Alpha is correct. The reflector is longer and the director is shorter. How do increasing boom length and adding directors affect a Yagi antenna? A, gain increases. B, beam width increases. C, front to back ratio decreases. Or D, front to side ratio decreases.
Alpha.
Alpha.
Alpha is correct. The gain increases. What does front to back ratio mean in reference to a Yagi antenna? A, the number of directors versus the number of reflectors. B, the relative position of the driven element with respect to the reflectors and directors. C, the power radiated in the major radiation lobe compared to that in the opposite direction. Or D, the ratio of the forward gain to dipole gain.
Charlie.
Charlie.
Charlie is correct. What is meant by the main lobe of a directive antenna? A, the magnitude of the maximum vertical angle of radiation. B, the point of maximum current in a radiating antenna element. C, the maximum voltage standing wave point on a radiating element. Or D, the maximum or the direction of maximum radiated field strength from the antenna.
Delta.
Delta.
Delta is correct, even though I couldn't pronounce it. The direction of the maximum radiated field strength from the antenna. What is the following? Which of the following can be adjusted to optimize gain, front to back ratio, or SWR bandwidth of a Yagi antenna? A, the physical length of the boom. C, the number of elements on the boom. C, the spacing of each element along the boom. Or D, all these choices are correct.
Delta.
Delta, all these choices are correct. Which HF antenna would be the best to use for minimizing interference? A, a quarter wave vertical antenna. B, an isotropic antenna. C, a directional antenna. Or D, an omnidirectional antenna.
Charlie.
Charlie is correct, a directional antenna. Which of the following is an advantage of using a gamma match with a Yagi antenna? A, it does not require that the driven element be insulated from the boom. B, it does not require any inductors or capacitors. C, it is useful for matching multiband antennas. Or D, all these choices are correct.
Alpha.
Alpha is correct.
And why would that be, Daniel? Remember when we put those together up at Fort Flagler? I know there was a gamma match, but what does it do?
It's going to find the element that matches its frequency on the thing, and I'm not sure why on that one.
Yeah.
I'm not sure why. And by the way, on the other question in here, the approximate lengths of the driven element of a Yagi antenna.
Yeah.
Yagi, you've got the reflector and the director, which are passive. You tie the coax or the feed line into the driven element, and that's both halves, the center and the shield. That's going to make the driven.
Right,
On
so
the,
they're
on the
treating it
Yagi.
as one big element. Yep.
Yeah, and that's going to be the half wave. Yeah. If you're looking just after the dipole, it's a quarter wave. But you're looking at Yagi, it's the full thing. Because the other elements are passive. They don't have power driven to them.
Thank you.
And except for the gamma match, you don't have to separate the elements off.
Okay. What is a beta or hairpin match? A, it is a shortened transmission line stub placed at the feed point of a Yagi antenna to provide impedance matching. B, it is a quarter wavelength section of 75 ohm coax in series with the feed point of a Yagi to improve the impedance matching. C, it is a series capacitor selected to cancel the inductive reactance of a folded dipole antenna. Or D, it is a section of 300 ohm twisted lead or twin lead used to match a folded dipole antenna. Beta or hairpin match. Alpha is the correct.
Remember stub.
Yeah. All right, loop antennas. 6 questions. What configuration of the loops of a 2-element quad antenna must be used for the antenna to operate as a beam antenna, assuming one of the elements is used as a reflector? A, the driven element must be fed with a Balun transformer. B, there must be an open circuit in the driven element at the point opposite the feed point. C, the reflector element must be approximately 5% shorter than the driven element. Or D, the reflector element must be approximately 5% longer than the driven element.
Delta.
Delta is correct. 5% longer than the driven element. Approximately how long is each side of the driven element of a quad antenna? A, 1/4 wavelength. B, 1/2 wavelength. C, 3/4 wavelength. Or D, 1 wavelength.
Alpha.
Alpha, right?
Alpha is correct. A quad antenna uses a 1/4 wavelength on each side.
Well, yeah, and it's a full wave antenna, a quarter on each side. Yes.
Okay. How does the forward gain of a 2-element quad antenna compare to the forward gain of a 3-element Yagi antenna? A, about the same. B, about 2/3 as much. C, about 1.5 times as much. Or D, about twice as much.
Alpha.
Alpha is correct. They're about the same.
I can
Gain
tell you
is the-
though, I can
Go
tell
ahead.
you when we were kids and we built back 60s, it was amazing how our readings, our signal reports were phenomenal all over the planet when you put up a quad.
The other thing about a quad, you have more wire out there, so it's less susceptible to fading. So it is you'll hear quieter signals that or you tend to fade out on the Yagi.
Yeah. The other thing I liked about what Kassler said was that if you do the feed point on a quad at the bottom, even though it's physically vertically polarized, it becomes horizontally polarized when you feed it at the bottom or the top. That's really strange, but interesting and useful.
Yeah. In which direction is the maximum radiation from a portable VHF/UHF halo antenna? A, broadside to the plane of the halo. B, opposite the feed point, C, omnidirectional in the plane of the halo, or D, towards the halo's supporting mast?
Charlie.
Charlie is correct. Omnidirectional in the plane of the halo. In which direction or directions does an electrically small loop less than 1/3 wavelength in circumference have nulls in its radiation pattern? A, in the plane of the loop, B, broadside to the loop, C, broadside and in the plane of the loop, or D, electrically small loops are omnidirectional?
Bravo.
Bravo is correct. Broadside to the loop.
I'm trying to visualize broadside because I hadn't seen this term come up before. I mean, is that, can
90
you,
degrees.
So you have
Right
this
angle, isn't it? 90
circle and it's, 90 degrees.
It's very counterintuitive to me.
If you're looking through the circle, that's the direction the radiation is going.
That's the null.
Yeah.
Yeah.
the null is going,
That the null is the null is going through the circle.
okay,
If you're looking through the circle, that's the direction the null is going.
Yeah, so that's on 7-14, figure 710.
Yeah, that's counterintuitive, but whatever.
Baker is correct. Broadside to the loop. What is the combined vertical and horizontal polarization pattern of a multi-wavelength horizontal loop antenna? A figure 8 similar to a dipole. B, 4 major loops with deep nulls. C, virtually omnidirectional with a lower peak vertical radiation angle than a dipole. Or D, radiation maximum is straight up.
early.
Charlie is correct. Okay, 7.4. We're almost done. Specialized antennas, 8 questions. What is one disadvantage of a directly fed random wire HF antenna? A, it must be longer than one wavelength. B, you may experience RF burns when touching metal objects in your station. C, it produces only vertically polarized radiation. Or D, it is more effective on the lower HF bands than on the higher bands.
Bravo.
Bravo is correct. You may experience RF burns when touching metal objects in your station.
Sounds pretty nasty.
Yep, I played with a random wire one time when I was out in the field, and yeah, it lights you up a little bit. You go, yikes! Kind of like those cattle
Yep.
Cattle prod.
prod
Yeah.
thingies or the cattle fencing. Yeah, I
Simply-
did that too.
Simply shocking.
Simply shocking. How does the gain of a 2-3 element horizontally polarized Yagi antenna spaced vertically 1/2 wavelength apart typically compare to the gain of a single 3-element Yagi? A, approximately 1.5 dB higher. B, approximately 3 dB higher. C, approximately 6 dB higher. Or D, approximately 9 dB higher.
bravo.
Bravo is correct, approximately 3 dB higher. What is the primary purpose of antenna traps? A, to permit multiband operation. B, to notch spurious frequencies. C, to provide balanced feed point impedance, or D, to prevent out-of-band operation? Alpha is correct, to permit multiband operation.
There, I thought they were to capture wandering antennas.
Oh,
Right.
it would be nice to prevent you from out-of-band operation.
I thought they were supposed to catch aliens.
There you go.
Antenna traps.
Mouse traps.
Yep.
What is an advantage of vertical stacking of horizontally polarized Yagi antennas? A, it allows quick selection of vertical or horizontal polarization. B, it allows simultaneous vertical and horizontal polarization. C, it narrows the main lobe in azimuth. D, it narrows the main lobe in elevation.
Delta.
Delta is correct. It narrows the main lobe in elevation. Which of the following is an advantage of a log periodic antenna? A, wide bandwidth. B, higher gain per element than a Yagi antenna. C, harmonic suppression. Or D, polarization diversity.
Diversity. Uh-oh.
Diversity.
Alpha.
Alpha is correct. Wide bandwidth.
You know, going down I-5 on the right side of the freeway, just opposite Fort Lewis, not Fort Lewis, but the Madigan Hospital. That's the Berkeley exit. If you look off to the right, you'll see a log periodic at Camp Murray for the National Guard. It's a big one.
Oh,
Yeah, you can
Huh.
see it from I-5 every time you go by there.
I'll have to look. I didn't notice that all these times I've gone up and down. I remember looking at the buildings, but I didn't pay attention to the
Yeah,
antennas.
it's tucked back in there, but you can see it really plainly. Yeah.
Which of the following describes a log periodic antenna? A, element length and spacing vary logarithmically along the boom. B, impedance varies periodically as a function of frequency. C, gain varies logarithmically as a function of frequency. Or D, SWR varies periodically as a function of the boom length.
Alpha, right?
Yep.
Correct answer is alpha. Element length and spacing vary logarithmically along the boom. They had to get that logarithmically in there as many times as possible.
No hats.
Yeah, capacitant hat. What is the primary use of a beverage antenna? Oh, sorry.
It's for hydration.
Yeah.
A, directional receiving for low HF bands. B, directional transmitting for low HF bands. C, portable direction finding at higher HF frequencies. Or D, portable direction finding at lower HF frequencies.
Alpha.
Scratch those portables out of there.
Yeah, we put
Alpha
one
is
up.
correct.
We put one up for receiving in East Texas a couple, 3 years ago with a buddy of mine. And we only put it up about 12 feet off the ground, but it was 500 and some feet. So it has almost no terrestrial noise and it picks up, signals like crazy. It's just amazing. The gain.
Too bad it doesn't transmit very well.
Nope. It's
Yeah.
just for receiving.
Howard Schultz, one of our other instructors, made a Yagi out of beer cans and called that a beverage antenna.
I love it.
Nice.
Yeah, it had a good head on it, I guess.
Yeah. Which of the following is a disadvantage of multiband antennas? A, they present low impedance on all design frequencies. B, they must be used with an antenna tuner. C, they must be fed with open wire line. Or D, they have poor harmonic rejection.
Oh,
Delta, they have poor poor harmonic rejection.
In other words, they're noisy.
Last section, feed lines, 14 questions. What type of device is often used to match transmitter output impedance to an impedance not equal to 50 ohms? A balance modulator, B, an SWR bridge, C, antenna coupler or antenna tuner, or D, a Q multiplier.
Charlie.
Charlie is correct, an antenna coupler or antenna tuner. Which of the following factors determine the characteristic impedance of a parallel conductor antenna feed line? A, the distance between the centers of the conductors and the radius of the conductors. B, the distance between the centers of the conductors and the length of the line. C, the radius of the conductors and the frequency of the signal. Or D, the frequency of the signal and the length of the line.
Alpha.
Alpha is correct. What are the typical characteristic impedances of coaxial cables used for antenna feed lines at amateur stations? A, 25 and 30 ohms, B, 50 and 75 ohms, C, 80 and 100 ohms, or D, 500 and 750 ohms? Baker is correct. Bravo is correct. 50 and 75 ohms. What is the typical characteristic impedance of window line, parallel transmission line? A, 50 ohms, B, 75 ohms, C, 100 ohms, or D, 450 ohms?
Also right.
Yep. Window line
see-
is
You'll see 300, 450, and 600 ohms on there. So that's kind of, I looked at that question going, huh? But the 300 is your TV twin lead. 450 and 600 are also common.
okay. What might cause reflected power at the point where a feed line connects to an antenna? A, operating an antenna at its resonant frequency. B, using more transmitter power than the antenna can handle. C, the difference between feed line impedance and antenna feed point impedance. D, feeding the antenna with unbalanced feed line.
Charlie.
Charlie is correct. The difference between the feed line impedance and the antenna feed point impedance.
You have two matching points on in a transmission system. The transmitter to the feed line and the feed line to the antenna.
Okay. How does the attenuation of coaxial cable change as the frequency of the signal it is carrying increases? A, attenuation is independent of frequency. B, attenuation increases. C, attenuation decreases. Or D, attenuation reaches a maximum of approximately 18 megahertz.
Bravo. Right.
Bravo is correct. The attenuation increases. In what units is RF feed line loss usually expressed? A, in ohms per 1,000 feet. B, in decibels per 1,000 feet. C, in ohms per 100 feet. Or D, in decibels per 100 feet.
D for decibels.
D for decibels per 100 feet is correct. What must be done to prevent standing waves on an antenna feed line. A, the antenna feed point must be at DC ground potential. B, the feed line must be cut to a length equal to an odd number of electrical quarter wavelengths. C, the feed line must be cut to a length equal to an even number of physical half wavelengths. Or D, the antenna feed point impedance must be matched to the characteristic impedance of the feed line.
Delta.
Delta is correct. If the SWR on an antenna feed line is 5:1 and a matching network at the transmitter end of the feed line is adjusted to 1:1 SWR, what is the resulting SWR on the feed line? A, 1:1, B, 5:1, C, between 1:1 and 5:1, depending on the characteristic impedance of the line, or D, between 1:1 and 5:1, depending on the reflected power at the transmitter.
Bravo.
Bravo is correct, 5:1. What standing wave ratio will result when connecting a 50 ohm feed line to a non-reactive load having 200 ohm impedance? A, 4:1, B, 1:4, C, 2:1, or D, 1:2?
Alpha.
Alpha is correct, 4:1. What standing wave ratio will result when connecting a 50 ohm feed line to a non-reactive load having 10 ohms impedance? A, 2:1, B, 50:1, C, 1:5, or D, 5:1?
Delta.
Delta.
Delta is correct. What standing wave ratio will result when connecting a 50 ohm feed line to a non-reactive load having 50 ohm impedance? A, 2:1, B, 1:1, C, 50:50, or D, 0:0?
Bravo.
Bravo is correct. What is the interaction between high standing wave ratio SWR and transmission line loss? A, there is no interaction between transmission line loss and SWR. Or B, a transmission line is lost. High SWR will increase the loss. C, high SWR makes it difficult to measure transmission line loss. Or D, high SWR reduces the relative effect of transmission line loss.
Bravo.
Bravo is correct.
So if you have a transmission line that's not lossy at all, it's very highly efficient, a high SWR won't increase that loss?
You know, still having a high SWR.
What do you think about that, Daniel?
Every transmission line has some loss to it.
Right, but you can get
Right.
real low loss if you spend the money. I guess you wouldn't have a
Yes.
high SWR. No, you still could. I
Yeah,
thought
You're
sure.
The
SWR,
low
how many
loss,
things-
the low loss transmission line will take longer to dissipate the heat. And the standing wave will run back and forth longer in that, but it's still going to dissipate the heat if it's not matched. It's not going to get off as an antenna, as a radio wave.
So if you have a high SWR with a low transmission line loss, it'll still increase the loss, won't it?
Mhm.
A high
Because you have
transmission-
high SWR.
Yeah. I don't know. It's the way that's phrased. It sounds like if
Yeah.
your transmission line isn't lossy, high SWR won't increase the loss. I thought it always did. That's why I'm bringing it up. So,
Yeah.
okay.
B is correct.
Thank you.
What is the effect of transmission line loss on SWR measured at the input to the line? A, the higher the transmission line loss, the more the SWR will read artificially low. B, the higher the transmission line loss, the more SWR will read artificially high. C, the higher the transmission line loss, the more accurate the SWR measurement will be. D, transmission line loss does not affect the SWR measurement.
Alpha.
Alpha is correct.
Woohoo.
Dip, 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 dip. That's all, folks.
Look at that.
Thanks, Porky.
Dip, 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 dip. Okay. So, we are done with chapter 7. So we are almost done with the class. We have 2 chapters left. Chapter 8 is on propagation. It's 13 pages. There's 38 questions and about 40 minutes of video. And then chapter 9 is electrical and RF safety, and it's only 15 pages. And it has 26 questions and 45 minutes of video. So what I'm proposing is that we finish up on Wednesday. Oh, next Tuesday is the Mike and Key board meeting. So I'm going to have to bounce it to the Wednesday again. Sorry about that, but I'd like to finish chapter 8 and chapter 9 both. So that will be done on Wednesday, March the 3rd. And that'll be 64 questions and about an hour and a half worth of video.
Sounds good.
How's everybody doing on sample tests? Or
I'm kind of stuck at about 70%.
What sections are you missing on?
I seem to be missing on the band plans and the calculations.
Which calculations?
Most of them. I just can't get the formula straight.
Okay.
one thing I would
Did you go over that?
go ahead.
Did
The
you go
cheat
over that
sheet?
handout we had from Microhams
That helps a little bit.
on the formulas? It's 4 pages.
4 pages.
Yeah, we sent it out 3 weeks ago, 4 weeks ago.
Oh, no.
Okay.
Would that help?
That will help. That will list the different formulas.
Oh, okay.
It's in kind of a nice abbreviated format, so I think that'll help.
Okay.
It is this one here. Oops. Come on. Oh, geez, Louise.
You were close.
What is this thing doing? It's like not letting me move things around. There we go. It's like my mouse wasn't working. Yeah, so this is the one we were talking about.
Can you page down to the formulas? That has some of them at the bottom.
Yeah, this is a general, and then there was the other one that was also attached. Yeah, here's what we were covering tonight, the dipole lengths.
Yeah, that I pretty much got. Dave was very helpful on the antenna calculations.
You notice at the bottom there it was 468 rather than 494.
Mm-hmm.
Yeah. Yeah, there was another one that was
Yeah, where was that other one?
text study sheet. here's band plans, but it's more for technician.
Right.
And there's all the Ohm's laws and the conversions. Yeah, and that's the end of that one.
Okay.
Okay, Peter had to bail out. The other thing I was going to suggest was if you can find the area that you were having questions with, there is in the test section. Where is it? Where'd my screen stuff go? You could always go to review by the chapter
Mm-hmm.
in the ARRL and go through that section again. And then if you can go ahead and like make up a list of the few things that you're having questions on and send it to us and we'll go over them again
Yeah.
in the next class.
What Jim is saying, write the question numbers down that you're
Yeah,
missing.
write the question numbers down and we'll go over them again.
Okay.
And say if you miss 5 in chapter 5 of 3 tests, then we need to go over, need to study chapter 5. If you're
Yeah.
missing kind of all over the place, maybe we can find a pattern to help you out.
Yeah.
Right. Okay.
That was the one thing that I did like about the ARRL exam review. If you had a section or a chapter that you were questioning, you could really pound on the questions and hopefully get through them on there. Because the other ones review by sub element, you're jumping all over the book.
Hmm.
And then the ham study, that's plain almost like the regular test where they grab, a few questions where you're actually practicing for the exam.
Yeah. Yeah.
Good question. I'm glad you brought that up.
Yeah.
Hmm.
Yep. So now's the time because I'm going to request a few links for signing up for the online tests. Scott from our Mike and Key VE team, he sent 3 dates already for the technician people because they're going to be like the general class. They're going to be finishing up next week. So he's going to have some dates carved out just for the technicians. But the general people, there's more. There's, what did I say, about 14 in the last round.
Mm-hmm.
So about 14 people, and the technician had about 10 or 11. But we'll get some dates for you guys, and it'll be special for just our class, for the general class. But we don't want to do it until everybody feels comfortable, and that we don't want you to waste time and money, going to these tests if you're not ready for them.
We'll be having tests throughout the month. My brother wants to have his tests in April for the extra. So we're having tests, but we need to have a lot more tests when you get close to the end of the class here.
Yeah. And if you're not ready, we'll continue and do some more meetings where we can maybe spend a whole meeting and just go through the test together. Pull up a random test and everybody kind of go around and answer the questions and kind of, work on them that way too.
Or as you bring a list of questions, we'll go over your questions and try to help you out.
Yeah.
Okay, that's great. Now, here's another question. If you take the test and flunk, when can you retest?
Immediately. With Scott's thing, you have to get a time slot in here. With the Laurel, we can just turn around and give you another test. And I'm trying to look for the first Saturday in March to have a test, probably 2:30 in the afternoon. If you fail there, you can go over, explain the questions you missed, and then go ahead and give you a second test.
Okay,
That's the in-person test. And I got to get a room set up on that.
okay,
It's also a free testing situation.
oh, excellent.
So there's no penalty if you miss one. But we always hate to turn you away when you got 23, 24 right. We like to give you a second test anyway.
Yeah.
Yeah,
You need 26.
26.
That's the magic number.
Oh, is that right?
That's the magic number for tech.
thought it
in
was
general,
80.
Yes,
I thought it was 80%.
as 74%.
Oh, it's 74%.
Yeah.
You
Oh,
gotta get a C plus.
Yep. So if you're doing 70s, you're right at the hair's edge. You just need a couple more boosts and you'll be there.
And we've got 2 more sections to do next week. You may be there.
Yeah. Yeah. We still
Yep.
have 2 sections.
okay, so 74%.
Yep.
You're close. You're close.
Wow.
And a pass is a pass. Once you make when I did my extra class, there's 50 questions and you needed, what was it?
37.
37. And they came around and they said, what do you think your number is? I said 37. And I just said, I think I'm like right at the hair's edge. And he goes, you got a 37.
Oh.
And I don't care. A pass, it's a light switch, baby.
As soon as you stand up, that's over.
Yeah, I said, it's done. 37, a pass is a pass. You know, I'm not one of those that, oh, I did a perfect score.
Oh, I don't care. Yeah.
When you get a perfect score, they come around there and they say, you overstudied.
Yeah.
I like the pass is a pass.
Yeah.
Some people say, just tell me if I passed or I didn't. They don't want to know the number. But yeah, we'll send us a list of the questions and we'll review and get you closer. And again, there is, like Daniel said, there is 2 more chapters. So we still have another section to go on.
Okay. Great.
Thanks, Jim. Thanks, Daniel.
Cool. All righty.
Thank
If
you.
there's nothing else, I'm going to go ahead and stop the recording.